All right, we're looking at starting to talk about monomials, binomials, adding them, subtracting them, multiplying them, all that good stuff. And so we're starting out with monomials. So first off, what is a monomial? So a monomial, mono means one, and then that monomial is either a number, it could be a variable, or it could be a product of both a number and a variable. So product of both. So examples of that, you could just have something like the number 5. That would be considered a monomial. Or you had like 17x, or just y. You could get as complicated as doing something like negative 15 a to the third bc. So all those would be considered monomials. I even got an example down there of a fraction one, so 1/3 c d squared. So it's basically a string of variables and numbers all multiplied together. So for this one in the middle, for instance, you have a negative 15 times a to the third power times b times c. And so these are variables that we don't know right now, but you use them to plug into an equation. We're going to get them in the simplest form as possible, so that your example of using them would be that whenever it gets used, someone would have numbers that they would plug in. You want them to be able to solve that as easily as possible. So when we're looking at monomials that have the same variables and exponents, we're calling those like terms. So you can think of it as down here on your examples, I have negative 15 a cubed bc. Think of this as a word. As long as it's the same word, you can combine them because they're like terms. So if this is negative $15 plus $6, and you'd say you had negative $9 for that. Instead of that, it's just a string of variables and exponents that are at the end instead of numbers. So since those are like terms, to add or subtract them, we will just combine like terms. And last but not least, make sure that you don't change the variables or the exponents on this. Those stay the same. If you're adding dollars and dollars together, it's still just dollars. So adding a cubed bc plus another amount of a cubed bc, it'll just stay as the same amount. So on this number 3, for example, that I just talked about, when we basically do negative 15 plus 6, which would give me a negative 9, and all this at the end stays the same, a cubed bc. So just combining them, that's all we're doing. And let's go over a couple more examples. If I have 3 y squared z to the third minus 4 y squared z to the third, all I would do for this is take, since they are, and I'm checking to make sure, They're both y squared z to the third. So I just do 3 minus 4, which gives me a negative 1, or just a negative y squared z to the third. Make sure that you're checking, because if you have something like 4x y squared plus 2x squared y, now these are not the same terms. They both got x's and y's, but for one of them the y is squared, the other one is the x is squared. So if I were to put numbers in for x and y, the value of that whole term here wouldn't come out to the same. So multiplying that by 4 and this by 2 doesn't give you multiples of the same number. So these, I would just, since they don't combine, I'd just rewrite down the same thing. 4xy squared plus 2x squared y. Other than that, you're going to run into some that have multiple terms down here. So when you're looking at these, number 11, for example, 13w squared plus 9w plus 4w squared minus 31w. Kind of the same thing we've been doing, combining like terms. So the w squareds would go together. 13 plus 4 would give me 17 w squared. And then positive 9w and negative 31w would end up giving me a negative 22w. So basically, as long as they are the same terms, you combine them together by adding or subtracting, and that's your answer. Quick and easy, 1 or 2 steps. And just remember, if it says like this negative m squared n, you can have that invisible 1 show up. So you'd be subtracting 1 from the 10 up here. Okay, so that is your adding and subtracting with monomials.